All right, so today in class we went over the slope of a line. Refer to these notes as you're doing the assignment that I handed out today. Some important things to remember about the slope of a line. Yes, it is the letter M that we will be using for slope, so it'll be M equals something. I don't exactly know the history of why, but we're just going to use that. It is the vertical rise with a horizontal run. So our top numbers, and when we got into graphing and counting out the slope, you need to know that your top numbers, your numerators, go up or down depending on whether they're positive or negative. So a positive goes up, a negative goes down. And your bottom number indicates left and right. So it's right if it's positive, left if it's negative. And then we talk about this formula, which is basically your change in y's or your change in x's. So when you subtract or take the difference between your y's on the top, the difference in your x's in the bottom, that mathematically we can figure it out rather than just counting on a graph. We'll do an example of that in a second. Equivalent fractions was an important piece too. We have to know that any positive slope, meaning the fraction that is indicating a positive slope, can be written as either two positives over each other or two negatives over each other. So if I have 5 over 2, that's also the same as negative 5 over negative 2. They will both fall within that line of the graph. And also it's important to know that whenever you see or you're checking your answers, if it's a negative answer, let's say negative 1/2, it'll be written as negative 1 over 2. The negative will just be out front right here. When we're counting, we have to know that it can also be written as either negative 1 over positive 2 or positive 1 over negative 2. If it's a negative slope, the negative is either going to be associated with the numerator or the denominator, not both. Both would indicate that it's a positive. We also spent a lot of time in class talking about how if we look at a graph, we should be able to determine whether the slope is going to be positive, negative, have no slope at all, or is going to be undefined. So if we read from left to right and it is going uphill, it's going to be positive. Think about it, you're climbing up a mountain, so that slope would be positive. If you're going downhill, like down a ski slope, that would be a negative. You're actually losing ground as you go downhill. You're gaining ground as you go uphill. If it's a flat horizontal line, that will be a slope of 0, and if it is a vertical line, it is an undefined slope. And when we do the math and we use these formulas, you'll see that our numerator in this case will come out as 0, and over here our denominator will come out as 0. So there's some examples like that on your homework where you're going to need to know the difference between that. Using the graph to find the slope, here were our steps. We talked about identifying two known points. Here would be a known point. It's where our line crosses an x and a y axis, or where you can indicate, where you can identify what the ordered pair is. So this would be, for example, 0, 1, 2, 3, 4. This would be 0, negative 4. This would be 1, negative 2, and so on. All right, so the way that we can use the graph to find the slope, and we'll talk about mathematically how to use these numbers to do that, but the way we use the graph to do it is you identify two known points. You can pick any two, but if they're not the two that are closest to each other, you're going to have to reduce that fraction. So I could pick this point and this point, but we're going to have to reduce that fraction. If we pick two that are right next to each other, we won't have to reduce it. Once you identify 2 points, then you count your vertical spaces from one to the other. So if I start from this and I go up 2, I'll indicate that as a positive 2 because I'm going up. And on the denominator, we go to step 3, count your horizontal spaces from one to the other. So I would go over to the 1, and that's to the right, so that is positive. So in this case, our slope, which is indicated by M, would be 2 over 1, or just 2. If I started, say, from this line dot and went down, well, that would be indicating going down 2, so that would be a negative 2. And to the left one, which would be indicated as negative 1, which is also 2. Negative divided by a negative is a positive. So depending on where you start, what you do, remember you have to pay attention to direction, which way you're going, up, down, left, right, positives and negatives, and then counting the spaces. It says to write the slope as a fraction. If it's a whole number, you can just leave it as 2 over 1, or you can leave it as 2. That's okay, but a lot of these are going to be fractions with a denominator that's not 1. Okay, the next part of the notes, we actually used the formula to solve for the slope. So we plotted these points in graph and we actually graphed it. So if I plot -1, 2, -1 on the x, 2 on the y, and then I plot 0 on the x, 3 on the y, which would be up here, and I draw that line, and we discussed how this looks like a positive slope because we're going uphill, we're gaining ground. And if I use the skill that I just used before, I could tell that my slope is going to be up 1 and to the right 1, which would be 1 over 1 or just 1. So mathematically we have to figure out how to solve that using this formula. So m equals, our slope equals, and I put y sub 1, y sub 2, and x sub 1, x sub 2, and it's the difference between them. Now these little sub 1s and these sub 2s, all that is indicating is which ordered pair is your first one and which is your second one. It doesn't matter which ordered pair you use as your first or your second. So we can call this one our first ordered pair and this one our second ordered pair. And that determined how I set up this problem down here. So I used y sub 1. So the y in my first ordered pair was 2. So that's why I put the 2 there. Then I subtract, and then I put the y in my second order pair, which was 3. 2 minus 3 gave me -1. On the bottom, whatever ordered pair you use for your first y, you have to use that one for your first x. So I have -1 minus, and then I have a 0, 0. So -1 minus a 0 is -1. So -1 over -1 equals 1. But you can think of it as a fraction as 1 over 1, either way. Let's say, for example, I used, I'm going to switch these around, and let's say I used my 3 as my first y. So 3 minus, then I have to go to my second y, which is 2, over, and now since I used 3 for my first one, I have to use 0 as my first x. So 0, and then minus, which is part of the equation, and then I have a -1. So I have minus a -1. Now in class we talked about a little bit of a trick. So we call it, whenever we're subtracting a negative, we can call it a positive. So the way that I did it in class, I always said it was 0 minus a -1, which then becomes a plus. So when I look at this, I have 3 minus 2, which is 1, over 0 plus 1, which is 1. So we get our same value, regardless of which ordered pair we use as our first ordered pair and which ordered pair we use as our second ordered pair. That was the notes that we covered for today. We assigned practice 6-1, and we used a couple of these examples. We did 1 through 3 in class. I'll make this smaller so you can see it. So we used 1 through 3 in class, then we did 4, 5, and 6 on your own. So I'll go ahead and take a look at problem 4. We're using the graph to find the slope. So in this, we count from a known ordered pair, which they already indicate for us. So we go up 1, 2, 3. So you go up 3, so that's our numerator, to the right 1. So that would be a 1. So remember, up is positive, and to the right is positive as well. So for number 4, our slope equals 3 over 1, or just 3. And you can see that all of these are going to be positive answers anyway because of the angle of our slope. 3 happens to be a -1, so I'll go ahead and jump back and do that. So here's a known point, here's a known point. So from this one we went down 2, so that was 1 space 2 space, so that's indicated by a -2. And then to the right 3, 1, 2, 3, so that's over a positive 3. So -2/3 is our slope for number 3. Now moving on, we're actually, for 7 through 15, you're using that slope formula to try to solve for for the slope. So I'll go ahead and do number 10 and number 11. So 10 is negative 2, 5, and 3, negative 4. So negative 2, comma 5, 3, comma negative 4. And we're using that equation, y minus y over x minus x. Depending on which y you use first, that's one that has to go in, that determines what x goes in first. So I can use, let's use 5 first. So I have 5 minus, and then I have a negative 4. So a negative 4 becomes 5 plus 4. So since I used 5 first, I have to use the negative 2 first down here. So negative 2 minus, because that minus is part of the equation, minus a 3. So that becomes 9. And negative 2 minus 3 is a negative 5. So we can just use that as our final answer. 9 over negative 5. The other problem that we were going to do was number 11. So I have 2, 4, and 6, 7. So 2, comma 4, 6, comma 7. Again, I'm using the same formula, y minus y over x minus x. So look at our y's. So I can start with this one. I can start with either the 4 or the 7. It doesn't matter. So I can say 4 minus, and then a 7, over, since I picked the 4 first, I have to do the 2 first. So I have a 2 minus a 6. So 2 minus 6. So that, do the math here. So this would be a negative 3 over a negative 6, or 2 minus 6 will give us a negative 4. And a negative 3 over negative 4 is the same as positive 3 over positive 4. Because remember, those are the equivalent fractions. So that would be the slope there. Be careful in putting your numbers. Remember, that second number you put in here is a negative in the ordered pair. It's going to become a positive. So you'll end up adding them together. Go ahead and do the rest of the assignment. Check your answers for accuracy. And come to class with any questions you may have.